Have you ever wondered how helicopters defy gravity and soar through the sky? Welcome to the fascinating world of helicopter aerodynamics and design, where physics and engineering collide to create these incredible flying machines. Helicopters, unlike their fixed-wing counterparts, have the unique ability to hover, ascend, descend, and fly in any direction, all thanks to the interplay of four basic forces: lift, thrust, drag, and weight. Each of these forces plays a distinct role in helicopter flight. Lift is the upward force that opposes the weight of the helicopter, allowing it to rise into the sky. It's created by the rotation of the main rotor blades, which are designed to push air downward and, in reaction, lift the helicopter upward. Thrust is the force that propels the helicopter forward. In a helicopter, this is achieved by tilting the main rotor disc in the direction of desired flight, using a mechanism known as the cyclic control. Drag is the air resistance that opposes the helicopter's motion. It's countered by the engine power, which drives the rotor blades. Helicopter design often involves a careful balance between power and drag to ensure optimal performance and efficiency. And lastly, weight. This is the force exerted by gravity on the helicopter's mass. Managing weight is crucial in helicopter design as it directly affects lift, fuel consumption, and overall performance. The interplay of these forces guides the design of helicopters. Engineers use these principles to make design choices, such as the shape and size of the rotor blades, the type of engine, and the overall structure of the helicopter. These decisions influence everything from the helicopter's flight capabilities to its fuel efficiency and safety. So, next time you see a helicopter hovering in the sky, remember the intricate dance of forces at play, making that incredible feat possible. Understanding these principles is key to appreciating the evolution of helicopter design. And as we move forward, these principles will continue to guide us, even as new technologies like artificial intelligence begin to reshape the future of aerospace engineering. Helicopter design has come a long way since its inception. It's a journey that began in the early 20th century when the first practical helicopter, the VS-300, was designed by Igor Sikorsky. A key milestone, this design introduced the single main rotor and tail rotor configuration, a design principle that remains fundamental to most helicopter designs today. As we moved into the mid-20th century, advancements in aerodynamics, materials, and propulsion technologies led to more refined designs. The Bell 47 helicopter, with its distinctive bubble canopy and exposed tail boom, became a symbol of helicopter design in this era. It was the first helicopter certified for civilian use, marking a significant step in expanding the role of helicopters beyond military applications. The latter part of the 20th century saw the emergence of the tandem rotor design, as seen in the Boeing CH-47 Chinook. This design, which features two large horizontal rotor assemblies, offers increased lift capacity and stability, making it ideal for heavy lift tasks. The 21st century has been characterized by a focus on performance, safety, and efficiency. The Eurocopter X3, for instance, introduced a hybrid design that combines the vertical lift capability of a helicopter with the speed of a fixed-wing aircraft. This design achieved a record-breaking speed of 292 miles per hour in 2013, demonstrating the potential of innovative design approaches. In recent years, there's been a growing emphasis on reducing the environmental impact of helicopters. The Bell Nexus, for instance, incorporates a hybrid electric propulsion system, paving the way for more sustainable helicopter designs. Safety has also been a key focus. Helicopters today are equipped with advanced avionics systems, providing pilots with real-time data to enhance safety and performance. These advancements set the stage for the next chapter in helicopter design, the integration of artificial intelligence. As we look ahead, it's clear that the evolution of helicopter design is far from over. The combination of AI and engineering ingenuity promises to usher in a new era of innovation, shaping the future of helicopter transportation in ways we can only begin to imagine. Artificial intelligence, or AI, is revolutionizing various industries, but what exactly is it? Well, in essence, AI is a field of computer science that mimics human intelligence, enabling machines to learn from experience, adjust to new inputs, and perform tasks that usually require human intellect. Within AI, we find subsets like machine learning, This is where algorithms are used to parse data, learn from it, and make informed decisions based on what it has learned. Think of it as teaching a child to recognize shapes. You show them several variations of a shape, say a circle, and over time they can identify a circle on their own, even if they've never seen that particular circle before. It's the same with machine learning. The machine is learning to identify and make decisions based on patterns in the data it has been shown. Deep learning takes this idea a step further. This subset utilizes artificial neural networks with several layers of nodes operating together to understand and process data. These layers create an artificial neural network that mimics the human brain, allowing the machine to not just learn from patterns, but to recognize and understand nuances and complexities in data. It can pick up on patterns and relationships that might even be missed by human analysts. These technologies are significant because they can solve complex problems and make accurate predictions. They can process vast amounts of data much faster and more accurately than a human can, making them invaluable tools in numerous fields. For instance, in the medical field, AI can help doctors diagnose diseases more accurately. In the financial sector, it can predict market trends. And in our case, in the realm of aerospace engineering, it can aid in designing more efficient, secure, and advanced helicopters. Now that we have a basic understanding of AI, let's see how it is currently being utilized in aerospace engineering. AI is already making waves in the aerospace industry. It's not just about robots assembling aircraft anymore, but about the intelligent systems that are reshaping the way we design, manufacture, and operate in the realm of aerospace engineering. One of the remarkable applications of AI in this field is predictive maintenance. You see, helicopters, like any complex machines, require regular checkups and maintenance to ensure they're in top-notch condition. AI, with its ability to process colossal amounts of data, can predict potential faults and system failures before they occur, saving time, money, and potentially lives in the process. Another domain where AI is making a significant impact is flight simulation. Traditionally, flight simulators were solely based on physics models, which, while accurate, could not account for every possible real-world scenario. Now, with AI and machine learning, simulators can learn from real-world data and provide a more comprehensive and realistic training environment for pilots. This advancement not only makes the training process more efficient, but it also prepares pilots for a wider array of possible situations. But it's not just training and maintenance where AI is carving its niche. Automated control systems powered by AI are becoming increasingly prevalent in aerospace engineering. These systems enhance the precision and stability of flight operations, reducing human error and making flights safer. For instance, AI can help helicopters maintain stability in challenging weather conditions, assist in navigation through complex terrains, and even take over the controls in case of human incapacity. So you see, AI is not just an abstract concept or a futuristic dream. It's a reality that's transforming the aerospace industry as we know it, and its potential is immense. But it's not all smooth flying. With great power comes great responsibility. And with AI, there are challenges to be met, problems to be solved, and ethical considerations to be made. These applications are just the tip of the iceberg. Let's explore how AI can address the challenges in helicopter design. Because as we move forward, AI isn't just going to be part of the solution, it's going to be at the heart of innovation, redefining the future of helicopter transportation. The future of helicopter design holds exciting possibilities with the integration of AI. Artificial intelligence, or AI, is poised to revolutionize helicopter design. By harnessing the power of machine learning and deep learning, we can optimize designs for better aerodynamics, efficiency, and performance. Imagine a system that could test thousands of design variations in a fraction of the time it would take a human. AI can do this, evaluating each design against performance criteria and learning from each iteration to produce a highly optimized final design. But AI's potential extends beyond just design optimization. It can also assist in material selection and structural design. With the ability to analyze vast data sets, AI can identify materials that are lighter, stronger, and more durable. It can also help engineers design structures that maximize these material properties. This could lead to helicopters that are not only more efficient, but also more resilient and capable. Safety and reliability are of paramount importance in aviation, And here, too, AI has a role to play. Predictive maintenance powered by AI can detect potential issues before they become problems, reducing the risk of in-flight failures. AI can also monitor the health of an aircraft in real time, providing vital data to pilots and ground crews. Perhaps one of the most exciting prospects is the development of autonomous helicopters. AI technologies are enabling unmanned flight, which could have a multitude of applications from cargo transport to search and rescue missions. The benefits of autonomous helicopters are numerous, including the ability to operate in hazardous environments where human pilots may be at risk. AI is already making waves in the world of helicopter design, and its influence is only set to grow. But as we harness this powerful tool, we must also navigate the new ethical considerations and regulatory challenges that it brings. While AI holds great promise, it also brings new ethical considerations and regulatory challenges. From ensuring the safety of autonomous flights to protecting privacy and maintaining accountability, we must tread carefully as we step into this new era of helicopter design. As with any groundbreaking technology, AI comes with its own set of ethical and regulatory challenges. Integrating AI into helicopter design and operation is no different. One of the major ethical considerations is safety. With AI in the cockpit, questions arise like, what happens if the AI fails or makes a mistake? Who is responsible? These are not simple questions to answer. It's not like blaming a human pilot for an error. We're dealing with complex algorithms that are often opaque, even to their creators. Then, there's the matter of privacy. Autonomous helicopters could potentially gather vast amounts of data, some of which could infringe on individual privacy rights. Balancing the benefits of data collection for improved safety and efficiency against the right to privacy is an ongoing ethical challenge. Accountability is another major concern. If an AI-controlled helicopter was involved in an accident, who would be held accountable? The AI, its creators, or the operators? The current legal framework is not equipped to handle these scenarios, and new regulations need to be developed to ensure accountability and justice. Regulatory challenges also abound. Regulators need to establish standards and protocols for testing and validating AI systems in helicopters. They must also address the issue of cybersecurity. As AI systems become more prevalent, the risk of cyber attacks increases. Ensuring the security of these systems is paramount, not just for the sake of the aircraft and its passengers, but also for the safety of people on the ground. Moreover, the integration of AI into helicopter design and operation also raises concerns about job displacement. As AI takes over tasks traditionally performed by humans, what happens to the pilots, mechanics, and others whose jobs might be made redundant? Lastly, there's the issue of public acceptance. Many people are wary of AI and may be uncomfortable with the idea of AI-controlled helicopters. Overcoming these fears and earning public trust is a significant hurdle. Addressing these concerns is crucial for the successful integration of AI into the future of helicopter transportation. So, what does the future hold for helicopter transportation? As we look ahead, we see a future of helicopter transportation revolutionized by the power of artificial intelligence. Imagine a world where helicopter designs are so efficient that they consume less fuel, emit fewer emissions, and provide a quieter, smoother ride. This isn't mere speculation. It's a future that's within our grasp thanks to AI. Artificial intelligence is set to play a key role in creating more efficient, sustainable, and accessible air mobility solutions. By leveraging machine learning and deep learning algorithms, AI can analyze vast amounts of data, identify patterns, and make predictions. This ability can be harnessed to optimize the aerodynamics of a helicopter, improving its efficiency and performance. In the realm of sustainability, AI can assist in selecting materials for helicopter construction that are lighter, stronger, and more durable. This not only reduces the weight of the aircraft, thereby enhancing fuel efficiency, but also prolongs the lifespan of the helicopter, making it a more sustainable choice. But perhaps one of the most promising potentials of AI lies in the realm of accessibility. The development of autonomous helicopters capable of unmanned flight opens up a world of possibilities. With AI at the helm, we could see a future where helicopters become a common mode of transportation, ferrying people and goods with unprecedented ease and efficiency. However, this future is not without its challenges. As we integrate AI into helicopter design and operation, we must also confront ethical considerations and regulatory challenges. Concerns about safety, privacy, and accountability must be addressed to ensure that this technology is used responsibly. But despite these challenges, the potential of AI to revolutionize helicopter transportation cannot be denied. From design optimization and material selection to autonomous flight, AI is poised to reshape the future of helicopter transportation in ways we can only begin to imagine. The future of helicopter design driven by AI holds exciting possibilities. As we venture into this new era of air mobility, we can look forward to a future where helicopter transportation is not just more efficient and sustainable, but also more accessible than ever before. We have covered a lot of ground today, from the basics of helicopter aerodynamics to the potential of AI in shaping the future of helicopter design. We've seen how the principles of lift, thrust, drag, and weight guide the design process. We've journeyed through the evolution of helicopter design, seeing the milestones of technological advancements that have improved performance, safety, and efficiency. We've delved into the complexities of AI, from machine learning and deep learning to neural networks and their significance in solving complex problems. We've explored the current and potential applications of AI in aerospace engineering, and the challenges that we face in integrating AI into helicopter design, including ethical and regulatory considerations. We've glimpsed the future of helicopter transportation, where AI plays a pivotal role in creating more efficient, sustainable, and accessible air mobility solutions. The sky is certainly not the limit when it comes to the future of helicopter design with AI.